Okay, so what have I got going on here? I claim that here. They're saying that most cars are going more than 5 miles an hour over the speed limit. The other thing I'm seeing is they aren't telling me a standard deviation here. So that's a flag for me. This is about a categorical variable. And the random variable, if you think back to chapter 5, that I'm looking for is are they speeding? Are they going more than 5 miles an hour over the speed limit? So that's a yes/no question. So this is a binomial experiment. And because I've got a sample of 50 cars, I know that, here, let me come back and get a pen. I'm going here. I know that, well, let's see. They didn't tell me a percentage. What if most is 50%? Is 0.5 times 50 more than 5? It sure is. And of course, that'd be the same for the converse of that, the 0.5 not speeding, right? So this is the binomial situation that we can use the normal approximation to prove. So in other words, this is a test of proportions. So we can forget about all that mumbo jumbo about binomial distributions. This is something where we can do a one sample proportion z-test. So in this case, so my claim is, here's my claim. I highlighted the claim already. So HO is, well, we know the proportion, we're saying the proportion is not greater than 0.5, not more than 50% are going faster than 5 miles an hour. Then H1 or HA will say it's greater than 0.5, and that's going to be my claim. So now I need to do I'm going to do a one sample, or one proportion, a z-test. And we could certainly calculate the mean and the standard deviation and find the z-score for it. Or we can also just use that David Lane applet. Not David Lane, I mean the Rossman chance applet. And I'm going to go grab that and bring that in for you. Okay, so I went out to that Rossman chance applet, and some things I want to make sure you see is I had to change this to one proportion. I had to do the drop down one to proportion. I had to type in the 29. See, because they had a sample of 50 cars, 29 of them were going faster than 30 miles an hour. So, and then it calculated the p hat for me. Then I had to click on test of significance. I had to click on this until it said greater than, and that matched my HO result. And then here's the test statistic. Here's the p-value. We see a 1% level of significance or 10% level of significance, and that's bigger than 10%. So we're going to fail to reject HO. So what does that mean in terms of the context of that claim that most cars were going faster than 5 miles an hour over?
Good afternoon.
So this is that flow chart for my notes, and what I want to show you how to use this is, does the original claim contain an addition equality? This just means, is the claim HO? Well, no, it wasn't. We said it was HA. Did you reject HO? I did not. So this is how I start my conclusion. I say there's not sufficient sample evidence to support the claim that that doesn't support the claim that most cars are traveling more than 5 miles an hour over the speed limit. Okay, and that's what you do. It's that easy. You don't have to do all the calculations, but interpreting the results is really important. If you want to use Dr. Stevens' phrasing on this, I think he has something like there's not enough data to support the claim that. And that certainly works too. I like the flow chart because it's visual. So hopefully that helps you out.